Alright, number 8 is balanced phonic redox reaction. Assume that it takes place in acidic solution, and then we have to have simplest integers. So anyway, first thing you have to do is mix it up into its half reactions, and so to be able to do that you have to assign oxidation numbers. So nitrogen here would be positive 5 with oxygen being minus 2. Zinc of course is 0, oxygen is minus 2, that means nitrogen is positive 4, and over here zinc is plus 2. So we can see that zinc goes from 0 to plus 2, so that's our oxidation half reaction. Zinc going to zinc plus 2. And then our reduced BC goes from 5 to 4, so that goes down. So my reduction half reaction would be NO3 minus going to NO2, no charge. We just double check the reaction right here, make sure that it didn't miss any minuses or pluses. The NO2 has no minuses or pluses, and the zinc is positive 2 right here. Alright, next step after that, balance everything except for hydrogen and oxygen, which is done here. And then the nitrogens are balanced here. Balance the oxygens with H2O, and I have three oxygens here and 2 here, so I'm going to need a water over here to get 3 O's. Balances the H's with H plus, and since I have 2 H's here now, I need 2 H pluses right here. And of course I don't have to do any for the zinc because there's no hydrogen or oxygen in that. Balance the electrons, or balance the charge with electrons, and I'm going to need 2 electrons right here to get this to be 0, so that's equal to 0. And then down here I have an overall charge of positive 2 and negative 1, so positive 1 here, and then over here on this side it's 0. So this I'm going to have to add an electron to this side to get that to be 0 on this side, to balance the 0 on this side. Okay, next I have to make the electrons equal to one another, and I have 2 here. I'm going to need 2 here, so I'm going to end up taking this entire reaction here and multiplying it by 2. So I end up with 4H plus 2NO3 minus plus 2E minus arrow 2NO2 plus 2H2O. And then I've got this zinc reaction right here, and I've got this NO3 minus reaction right here, and now I need to combine them and then cancel. And you can see that the electrons will cancel right away because there's 2 on this side and 2 on this side. So let's combo everything. I'll end up with zinc on this side plus 4H plus 2 NO3 minuses, arrow, and then over here I've got Zn positive 2 plus 2 NO2 plus 2 H2O. Now, see if anything cancels, and it looks like this all stays. There's no H's, there's no HOH's to cancel. And so then, if it's not in basic solution, I go to the last step and just check it, and this is in acidic solution. So let's check it for mass. 1 zinc, 4 H's, 2 nitrogens, 6 oxygens, and 2 times 2 is 4, plus 2 more oxygens is 6. So that's balanced. Then let's check it for charge, and I have 4 pluses and 2 minuses, so that means I've got positive 2 on this side, and over here I have a zinc plus 2, so it's positive 2 on this side, and then it's balanced, and there's my balanced redox reaction. Alright, last one. A voltaic cell, whose overall reaction has a standard cell potential of, calculate E cell for the non-standard conditions. Well, this is not going to be assessed in 2021 because of the pandemic. We didn't do what's called the Nernst equation, but if you did that, you'd have to take into account that the concentrations are not standard conditions, and you end up using the Nernst equation that involves 0.0592 divided by the number of moles of electrons transferred times the log of Q, and here's the Q value, products divided by reactants to the power of the coefficients, and then you subtract that out and you end up having a voltage drop of 0.02 volts for those different concentrations. Alright, that should do most of the practice test. Good luck on your studying up.